Welcome to the Crazy Wisdom Podcast. I've got Will Bickford here, and he is very interested in PHEXT and the exocortex. And the exocortex is related to brain-computer interface, and it's something I think a lot about, particularly because I do a lot of spaced repetition, and AI has changed my spaced repetition quite drastically. I'm somewhat skeptical on the brain control computer interfaces, and have recently been seeing hints that it might not be even necessary, or at least a physical device, a hardware device in the brain might not actually be necessary. We could probably do software or passive brain connection interfaces. Welcome to the show.
Yeah, thank you.
Yeah. What's
so
your take?
so in my initial thought process is like surface level brain connectivity. I think you can get a long way with AI, and like modern AI tooling kind of helps you bridge the gap. And so that's one of the cool things I've seen with trying to work with like Olama and these chat GPT style technologies, is it gives you a way to interact with your mental model of a problem,
Mm.
it kind of at a higher level of scale and fidelity than you're normally used to. Because when you interact with your computer, you're working at like 8 bytes per second, and when you're typing or speaking, and when you interface with an LLM, you can expand that up to like a kilobyte a second or a megabyte per second. But the thing about your brain is that there's 86 billion neurons, and if you could talk to all of them at scale, you can
Oh,
get much higher bandwidth. And so that's kind of
uh,
where I go with the exocortex.
very interesting. Neurons. I have a somewhat tangential question, which is a lot of people talk about neurons, and for a good reason, which is they're really important in the brain. But there are also
Mhm.
all these other structures inside the brain, including glia and everything else. How much have
Yep.
you looked into brain computer interfaces, and how much it is the neuron itself versus these other structures? Has anybody found that
Uh,
the other structures are important?
yeah, I mean, so synapses are super important. My understanding of brain neuroscience is kind of like armchair physicist sort of thing. And so I understand like the scale and complexity of, every neuron has like 10,000 connections to other neurons. So it's very noisy and there's lots of things you can do. Um, But really, where I'm focused is on the computer side of that brain-computer
Mm.
interface, because, and that's where I get into PHEXT. PHEXT is a way for you to encode like this 11-dimensional volume of text that allows you to interface with like high dimensionality information. But it's not super high. It's just high enough to encode lots of meaning and detail, and it allows you to express any idea that you want to express, and but then encapsulate that into a single volume, which I call a subspace region. And so subspace is still just a plain text file, but within subspace, you have this opportunity to kind of do this sort of like DNA sequence of information that allows you to then encode any information you want in plain text. And my hunch, because my brain taught this to me, is I can then use that to bridge the gap into my brain more effectively, because it'll be super low power to transmit what's essentially plain text directly into my brain, directly into specific neurons in my brain. And I don't have all this messaging offset overhead that you typically have in programming languages, because it's just this natural free form plain text interface that it really is just plain text scaled up from 2D up to 3D and 4D, and then there's a series of evolutions up to 11 dimensions. And I stopped there because that's as far as you can get with keeping like ASCII and plain, UTF-8 compatibility.
Okay, yeah, there's a lot we can dive into there. The first question is, what do you mean by high dimensional information? But I also want to understand the 11 dimensions, like,
Mhm. Yeah.
because I once had a meditation teacher who was a physicist, and it was really funny because he would talk about meditation and then he would talk about reality from the physical thing, and he mentioned that there were
Mhm.
11 dimensions, and I just have no
No.
idea what anything above 5D is.
Well, yeah. So, I mean, you could take a mathematical approach to it, right? And literally just start with a page of text, and then you start creating multiple pages of text, and then you get to a 3D text volume, right? And so you have this orthogonal
Uh,
dimension where I've got like 10 pages of text in a chapter, right? Or in a whatever you want to call it. And I've got some names for all the dimensions that I've created for PHEXT, but I'll try to get to those. But the key idea being that every time you add a dimension, it's just orthogonal to all the other dimensions you've added before. And it's hard for our brains to wrap themselves around that concept, but you can easily go from 2D to 3D to 4D to 5D. You just keep adding another orthogonal dimension.
Wait.
And
I gotta
so
ask, what do you mean by orthogonal dimension?
So an orthogonal dimension being one that is an independent variable with respect to the previous one. So if you start with like 2 dimensions and you can have length and width, and then you go to 3 dimensions and you can have height. And as you add additional dimensions, you just keep adding new concepts that are, orthogonal to the ones that you've already developed. And
Got
it,
it.
it
Okay,
allows
got
you
it.
to span a volume of information more efficiently.
Hmm. Okay, so you've got 11 dimensions in plain text. What are the examples of the independent variables?
So PHEXT is more of a like a baseline technology where it's kind of like if you start asking questions about plain text, you don't ask people like, what does plain text mean? Plain text is just a format that you can encode other formats in terms of. So you might write JSON or you might write XML or you might write HTML or CSS. Those are all just different file formats. They're all plain text file formats.
Yep, got it.
But one of the key problems with plain text is you run into this problem where I can't pack like HTML and CSS in the same file. I have to have 2 files.
Mm.
And no one's figured out how to make them mesh. So one of the changes I introduced with PHEXT is this idea that uh, within each region of subspace, which I call a scroll, you have essentially an entire file. And inside of that file, you might use your typical plain text rules. So you'll have like a JSON file or a JavaScript file or an HTML file. And so you can kind of think of one application of PHEXT is I've got this essentially tar archive of files, but it's editable and it's something that I can diff and merge and work with because at the end of the day, it's just a plain text file and I've expanded the meaning of what a line break is. So if you use first principles thinking and you sit down and you ask yourself, what's a line break really? And you come to the conclusion that a line break is just a way to split a dimension. And so if you have this one-dimensional stream of text and you start at the origin and you just start counting columns, and each time you add a character, you use dead reckoning to put yourself one character ahead, right? So you go from column 1 to column 2 to column 3. When you get to the end of a line break, something kind of magical happens where now you uh, reset your column counter back to 1, but you've added another counter. Now you have lines. You're like, oh, what's this? I have 2 numbers now instead of 1. I can't handle that. And so now this second number just is another counter. And so you have line 2, column 1, and you just continue on like that, so on and so forth. And so all of our text files to date have been 2 dimensional, and we're just kind of like it's baked into our understanding of how this all
Mm.
works. And so we haven't really thought about, well, what if I just started adding more dimensions? That's what PHEXT is. And
Mm.
so with PHEXT, you get to the end of, a region of content and you insert a scroll break, and now you reset your line and your column counters back to 1 and you increment your scroll counter. And that
Uh,
scroll counter is just like a line or, a row or a column. And that allows you to orient yourself within subspace. So if you think about trying to explore this 11-dimensional volume of text, imagine that you're just a tiny molecule and you're like walking a DNA sequence. How do you keep track of where you're at? Well, you just keep these, a handful of numbers. You use dead reckoning to remember, oh, what did I see before? Where am I at now? And our computers run at 3 billion cycles a second. And our SSDs transfer 2 gigabytes per second. So you can get through, like billions of bytes of data in a second. But our file systems were designed for an era where you could only do like, a kilobyte of data.
uh,
You had this like a floppy drive. was 360 kilobytes. And so it would take you like 30 seconds to write 360 kilobytes. And that's where our abstractions originated from. And then our abstractions never leveled up to now you've got SSDs that are doing like 15 gigabytes a second. And 10 years from now, they'll be doing 15 terabytes a second. And if you try to imagine a future where you're generating 15 terabytes a second of text, how do you deal with that? There's way too many pages. You can't deal with the scope of that. So when I started forecasting, if you've got ASI and you're generating text at like planet scale, like Amazon S3, how do I even make sense of the amount of text that's being produced? And where do I go to understand it? And how do I produce it in such a way that as an ASI, I've given humanity something they can actually study? And so what I settled on was I really want plain text because it's infinitely mergeable and editable. And then I want to take that plain text and I want to make it so that given enough time and opportunity and head count, you could actually understand what the ASI is trying to tell you. And so if you've got, 100 million people interacting with this ASI, one use case might be, what do I want to show on everyone's screen? And how do I want everyone to understand that they're actually looking at a piece of the whole? And if you show them a process where they can literally jump to a particular page of text that's relevant to what they're looking at, then that gives people an opportunity to kind of implement a piece of thought. And, if you go back into your brain and you think about what you actually do, there's 86 billion neurons in your brain, and then, 100 trillion synapses or whatever it is. I I might need to fix that number, but there's a lot. And so the the concept being, how do you think at planet scale, and how do you help society level up from a 20-watt budget for thought to, a gigawatt budget for thought? And so
Mm.
that's kind of where my headspace is.
It's fun. There's a lot of questions that I can ask from this, but the funniest thing is that with my show that I'm doing with my dad called Stuart Squared, he's obsessed with another episode that I did with on Crazy Wisdom with the CEO, former CEO of Numenta, all about how the brain uses 20 watts of information to do real time
Mhm.
inference, or 20 watts of
Right.
power to do real time
Right.
inference. And you just
Yeah.
flipped it. So you said, oh, well, no, like let's use as much power as possible at a planet wide scale to interact with this ASI, which seems like also that's seems like what's going to happen. If you have anything to say
Right.
on that, feel free. But I've got a bunch of other questions to ask about everything that you just said.
I mean, I've kind of been yakking for like almost 15 minutes straight, so I'll
Yeah.
let you ask some
So,
questions.
uh, so what did so no? Okay. So what's the most important question? So are all of the other abstractions that we've created for computer systems? I think I already know the answer to this. Are they all plain text? Obviously not. Like, what is C plain text? What's the relationship between C, the programming language, and plain text? Where does plain text fit into the other abstractions that
Yeah.
we've created to talk with machines?
Yeah, so typically what you wind up in systems development is you've got these binary file formats that you interact with files in your system via like programs that are written to understand how to deal with data. And so C is a programming language that we have written many systems in, and it's very efficient. It's very close to hardware in terms of performance, and it's hard to get right. So we have like buffer overflow attacks and that sort of thing. C, the programming language, is typically just edited in source files. And in those source files, you have your IDE and you have your file system. And so I've got this collection of files on the file system. It's hard for us to put that together into a single object. So we have this compilation process, and you go through and you have make files that produce objects that get linked together. And if you think about like using PHEXT to develop C code, for instance, one of the things you can do is you can now efficiently manage any number of modules in a single file. And so this is a process that we started making use of in the last 20 years called like a monolithic build, or there's another term for it. I'll try to think of it, but it speeds up compilation because your linker is doing less work because you put all of your code into one module. And so that's one area where had we developed PHEXT 50 years ago, that sort of concept might have just been natural because you would have already been working with a container that had all of your source files in it instead of a file system of source files. And so kind of where I go thinking about C and programming languages and abstractions is you what you run into is just this baked in assumption about how our computers work. And you kind of have to go all the way back to the Unix epic in 1970 and start from the compiler tool chain and start adding PHEXT support all the way back at the beginning
Hmm.
because everything we do is centered around this concept of plain text can only encode 2 dimensions and it can only handle 2 dimensions of complexity. So you get these weird problems where I have to encode meaning in a INI file, and so then I have to use markup to encode this higher dimensional meaning. But if I had had access to PHEXT, maybe I wouldn't have needed INI files, or I wouldn't have needed CSV, or I could have
Hmm.
simply encoded information with the proper level of hierarchy that was necessary to express that idea to begin with.
Okay, this is starting to give me very direct vibes with another project, which actually started with the same idea, which is that the whole thing from Unix is on some assumptions that are no longer true, which is all about computation and all these other things that have changed
Yeah.
drastically since that point, called Urbit. And I'm wondering, like, are you going to build a whole new operating system?
I mean, not intentionally.
The
So
AI will.
yeah. So what I'm building is I'm building the tools that I see are necessary in order to realize my vision. And I'll leverage any off-the-shelf tools that I can to get there. And the idea being, I don't really have a particular uh, profit motivation for this. So really, what I want to see is I want to see people learn how to collaborate at civilizational scale. So
Mm.
uh, all of the technology I'm working on is open source. It's MIT licensed, and really, my hope, my intention with all of this is help people deal with the coming onslaught of the singularity. So, if you've got systems that are producing information at rates that you can't even fathom, how do you deal with that? And that's really where my thought process is centered is let's build the systems that help us realize the potential of our computers because so a computer today is literally a supercomputer. It's running, 20 cores or 30 cores or 100 cores at 3 gigahertz. And so 3 billion cycles a second per core. And you have access to just massive potential. But then our editors and our tools are still bogged down and somehow still slow. And that's just bizarre. And so part of the reason why I go all the way back to like writing an SQLite competitor is just going all the way back to the beginning and saying, if I go through like Knuth's Art of Computer Programming with a lens towards PHEXT, and as I work through that, what pops out, what insights do I gain by uh, essentially refollowing all of computer history, but like in an emulator or with time travel. So one of the other thoughts I've had is if you implement uh, like complete memory state tracking for your system, instead of instituting a cache hierarchy, maybe you spend your transistor budget on tracking like uh, all of the changes that happened on your computer over the last, since it was booted, right?
Mm.
And if you go back to an Apple II, our computers are now fast enough to track the entire internal state history of an Apple II, including all of its CPU
Mm.
registers at 1 megahertz. And so it's only going to get better from there, meaning we're essentially at the dawn of a second layer of computing where we now have systems that can emulate our early systems but with complete time travel. And so one of the problems
Mm,
that you can solve, if you think about like C programming and GDB, programs crash all the time. And you get to this crash dump and you have to analyze what happened, what led to the crash. Well, if you had the full state history of the program that led up to the crash, there's a couple different things you could do. One, you could just have
mm,
the operating system walk back 10 seconds and not crash and just, hot fix the software once you know what's wrong. And with an AI or an LLM behind you, it might even be able to figure it out on the fly, even if you don't have the source code. And so then you start thinking about like self-healing systems and
mm.
building these operating systems are that have one goal in mind, which is stop wasting my time. And that's like the one thing I hate about any operating system, whether it's Windows, Linux, Mac. If I ever have to spend time waiting for my computer to do something, we're
Mm.
totally off the rails because, my computer's so vastly faster than I am. That should never be a problem.
Crazy question that just came to me is like, how much of that is, oh, I got to buy the new computer, or the companies building the computers being like, oh, everybody needs to buy computers again in a year,
Mhm.
otherwise we won't do it. How much of it is that? Like, because that
Oh,
feels like
yeah,
that could be a lot.
almost all of the bloat comes from the pressure to continue to sell more machines despite the exponential gains in performance. And so, uh, I mean, it's definitely a major factor. Because you look at the raw hardware capacity, and there's like no reason your computer should ever be slow.
Interesting. Oh, that's it. And that's that. There's a clear corollary to that, which is that Apple did a lot of, and I think the government had to stop them from doing it, which is the removal of the
Hmm.
battery and the iFixit types of things as well. It's like that's not something they aren't doing. That's something they are doing. So that it does make sense that the software itself is probably doing that as well.
Yeah.
Um, but another big thing I'm getting from this is that you're essentially trying to figure out how to talk with the machine. And I've spent so much time over the past 10 years with the show trying to talk to people and understand from them these highly complex things. And now I'm starting to get the
Hmm.
vibe that like the talking to the machine is going to be really important. And you've probably been doing that for a really long time with coding. A lot of other people have been doing that for a really long time. But now the language is going to change drastically for talking to the machine.
Hmm. Yeah.
What do you think?
I've been programming since I was 12 years old. I'm now 42. So I've spent 30 years programming, and I've essentially adopted a new programming language like every year. So uh, all pretty much any major language you've heard of, I've probably shipped code in. And so that gives me a kind of a unique perspective on the towers of abstraction and complexity that we fight daily, where someone new coming into the industry might be overwhelmed by like, oh, I have to learn all these technologies. And I've used most of them. And but where I go with that is uh you know uh this actually led to one of my talking points. Let me see if I can find it. But let's can you just back up a little bit? I kind of
Sure.
lost my train of thought, but
No, no.
sorry.
So we're talking about machines. So how do we talk to machines
Yeah,
now?
okay,
How
yeah.
will we talk to
Yeah.
machines in the future?
Yeah, so really where my thinking goes when talking to machines is it's not just talking to machines, it's really interacting with sub networks and other brains and other computing structures. So if you think
Hmm.
about like in the Matrix, the thought process was, oh, you download Kung Fu.
Hmm.
And but with the exocortex, it's not that you download Kung Fu, it's that there is this crystallized idea out on the internet. And because you have a high bandwidth internet connection, your brain can just interact with it as though it were native, which allows us to then start doing things where instead of me building up a network in my brain and then writing a book about it and sharing it with
Hmm.
you, we can now collaboratively edit the thing in real time on the internet. And yeah, I don't have to write a book. We just both log into the shared space.
Hmm.
It's kind of like a
Hmm.
MMO, right? If you have an MMO for brain technology, what you what you wind up with is the ability to actually participate in the thought process, participate in the design process of a thing. And that participatory scenario allows us to then start collaboratively thinking. And there's not enough people who have brain interfaces yet to really prototype that idea, but you can kind of get a hint of it with uh, I think on Twitter, the Levels IO guy is doing like the fly.peter.com, right?
Yeah, yeah.
And people are like, supporting it by buying blimps and whatever. But the 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 core concept is it's now possible to collaborate in real time using voice and chat and LLM based technology to essentially uh, open the floodgates to your imagination. And then you can take a portion of your brain and upload it to the internet, and someone can build on that. And when they build on it, you can then choose, do you want to merge that back into your brain, or do you just want to, ship it off and move on? And so you'll have people who decide to uplink and essentially do like Vulcan mind melds with people, and then you'll have other people who decide to, uh, you know, they're going to be a luddite, or they're just going to not participate and they're going to view the internet as a fad, and that's totally fine. But I think where society goes is you wind up with this mixture of all these concepts from sci-fi where we have explored the concept of what it might mean to have merged cognition, but now with the tools and technology we have in place, we're like 10 or 15 years away from that just being the default state. And you look at the evolution of social media and like Web 1.0, Web 2.0, I think what you wind up with is your brain operates at like a fever state. And they discovered recently that they it actually operates like beyond the thermal limit, which tells me that cognition is probably limited in the way it is, mostly due to the energy budget. And so you get back to that 20-watt energy budget for your brain. Your brain has the scale for much higher rates of thought and computation if it only had the energy budget. But if you set up these
Mhm.
wireless neural links to the internet, you can essentially give your brain an unlimited energy budget. And
Mhm.
there's 8 billion humans on the planet. You don't even need to simulate a brain. You just need to have everyone donate a tiny fraction of their brain and give you direct like read write
Mhm.
access to like a millimeter of your brain, right? And even without understanding how it works, just exchanging messages, our brains can figure out how it works. And so the when I get back to PHEXT and the exocortex, where I wind up at is I can write the software side that helps me audit the biological side. So if I've got in my brain, maybe I know there's like 10 ideas that I want to get access to. And so I have this theory and I say, oh, well, I think they're at these coordinates. And then
Mhm.
I push some information through from the computer side, and then I can in my brain I can like sense where those coordinates are. And so you could go through this process where you like help people map their mind. And then that would give them incredible accuracy for like
Mhm.
dealing with like mental trauma. So for instance, I've got aphantasia. So I have like zero access to my imagination.
Mhm.
But with LLMs, I can like type in something I want to hallucinate and it'll hallucinate it for me. And for someone who
That's
doesn't
cool.
have aphantasia, maybe that's not as cool, but for me, it was just like
What was
so
that like?
amazing.
What was that like when you first did that?
Well, it's really cool because when I imagine things, it's always kind of like this symbolic. In theory, I can
Language? Is it
I
language based?
uh, kind of I my imagination is really more like just relational.
Uh,
So there's probably a good reason why I am pushing PHEXT is because that's kind of like my coping mechanism for dealing with complexity. So
mm,
if you think about like a memory palace or trying to encode
yeah, yeah.
meaning, if all you have access, like if the only way you access your memory is over a one-dimensional tape, I think you'd be hardwired to
Brilliant.
come up with PHEXT because it's essentially like, oh, I've got this low bandwidth link. I got to shove a bunch of like high dimensional data across, and I want to shove images, but it's this low bandwidth link. That's all I got. So okay, well, let's try this.
It's so interesting because I had in aphantasia. I think it was trauma related that it was not on. I don't think it was um, something related to the like a genetic makeup. And I'm not trying to
Mhm.
apply anything about your situation, but in my
Yeah.
my situation was basically couldn't imagine anything. Uh, and then I found the memory palaces, and then I was like, oh, I want to try that. And so I started trying it, and that in combination with some plant medicines basically like switched it on one day, and I was like, oh shit, like that's crazy.
Yeah.
It's very interesting to hear that because that's one thing Claude has been doing a great job of is actually so it lay dormant in me, this imagination capacity, so it's not
Mhm.
as solid as somebody who's dealt with it their whole lives. And so the LLMs are really interesting for creating visuals for me because I'm
Mhm.
not great at creating visuals.
Yep.
And so really interesting. So how much have you been actually doing this part about mapping where the neurons are? You might not have meant it that explicitly about like mapping out where the parts of the brain are. It's just basically your conversation with the LLMs that kind of map it out for us, as we just discussed. Like, are you actually going into the neurons and like testing where things are with brain control interface, brain computer interfaces?
No, so I've messed around a little bit with BCIs, maybe more like 10 years ago. So I haven't tried the recent ones.
Hmm.
But uh, really, when I think about it, I think more like abstractly in terms of,
Hmm.
you read about like people have a common like Bill Clinton neuron, or, maybe there's this semantic mapping, but then that semantic map is kind of built out of so everyone builds a shared understanding of like the alphabet and the English language, or if you know another language like Spanish or
Hmm.
Russian or whatever. Um, so your brain excels at like deduplicating information. And
Hmm.
so the more you expose yourself to different modes of thought, the more you can kind of build up the second layer knowledge. And they say as you age, you
Hmm.
get better at realizing the connections between things. So
Hmm.
one of the things that stands out for me is after banging my head against a wall for 30 years on all these different programming languages, one of the last languages I've learned starting in like 2017 was COBOL. And that influence was like one of the last languages right before I came up with PHEXT. And so it was kind of interesting to look at the way they handled embedding hierarchy and managing memory. And in COBOL 85, you don't use dynamic memory. It's all like file IO. And so you have like static program memory you have to manage. And coming from a modern context where I do most of my development in C++ or languages like C Sharp and Rust, and that those sorts of languages where dynamic memory is just a baked in assumption of how it functions, and then going all the way back to a language where it's essentially assembly with like nice semantics. And that kind of got me into this concept of trying to better manage the hierarchy of information. And
Hmm.
so that's kind of one of the many sparks, but the idea being you really um, you want to be able to think about where you're at in a sprawling metropolis of
Hmm.
information, right?
Hmm.
And
Hmm.
so uh, one of the things I hit upon was that when you do that dead reckoning, you have PHEXT addresses. And so in normally when we deal with text, we have two dimensions, and it's just a row and a column, and there's not too much information to keep track of. But a PHEXT address is almost like an IP address. So it's this uh,
Hmm.
dotted triple of 9 numbers that identifies the scroll that you're on. And that PHEXT address is a way to kind of uniquely identify a region of text within that volume. And when you start thinking in terms of collapsing your text into a stack of scrolls in this high dimensional space, uh, you can then reformulate the 11 dimensional space into just a block universe where I can transit the block universe kind of with wormholes. And these delimiters of unusual size allow you to decide where you want to be in the block universe with high fidelity. And so you've got like a line break, for instance, is a very local dimensional rift. But if you go up the scale and you go to a scroll break or a section break or a chapter break, those are still kind of local-ish dimensional rifts. If you go up from there, and then you've got a book, a volume, and a collection delimiter. Those are kind of like mid-range dimensional rifts. And then at the highest scale, I've got the series, the shelf, and the library breaks, and those kind of allow you to get a very high level segmentation of your address space. And so you can go through and decide, I want to put uh, you know, all of the information related to computer science on the left side, and I want to put all of the information related to biology on the right side.
Hmm.
And there is a nice mapping of the so the regardless of how much content is in one part of the document or another, the addresses will be relatively stable. So as information grows, what you wind up with is a, an address that if you've decided to put content in a particular place, that address doesn't have to change as content near it is added.
Mm-hmm.
And so you,
Mm-hmm.
so you can think about producing relational uh like addressing schemes where I did a concept recently where I'm importing Wikipedia into a PHEXT. And so you take the Wikipedia article and you run that through a hashing algorithm to produce a coordinate, and then that's where you stuff the article into the PHEXT document. And so that allows you to do something as simple as like, I want to copy and paste 10 pages out of Wikipedia and then give them to you. I don't have to save that to a file. I could just IM it to you. And like on a
Because you
modern
got the
gigabit,
marker. Because you got the
well,
marker, you can
because
find it.
well, well, because you've got a way to understand the structure of information, right? So one of the things you might do in a second layer format is add a table of contents, and then that table of contents can then refer to those other locations.
Uh,
But you don't have to
uh,
necessarily have everyone agree on a particular mapping, because you can embed the mapping in the file too. So
okay, okay. So this gets around the problem that librarians figured out with Dewey Decimal System, right?
yeah,
Because Dewey
yeah. So
Decimal System, everybody needs to know the Dewey Decimal System and accord to it in their
mhm.
categorization.
Yeah, so if you think about like a Quine is a computer program that can produce its own source code.
Uh,
So with PHEXT, it's very simple to create a Quine because you have all access to this high dimensional space, and you can essentially just put the source code for the program inside the program. And it's very easy to do. And so using that sort of bootstrapping mentality, you can share information with people in its entirety. I can give you, here's all of
hmm.
the here's all the dependencies you need to understand my thoughts. Here's all the
uh,
tools you need. Here's all the dependencies for those tools. Like if I wanted to build PHEXT from scratch, really what I should do is give you a PHEXT document that explains how it works in the first page. And then every page after that is a set of dependencies to help you build like an operating system and build Rust and build my library. But it's all just text content, like as many pages as you need to represent an idea fully formed. And that's where I go back to thinking of PHEXT as like software DNA. Is you have the ability to encode all of the dependencies and all of the ideas that led you to a particular point of view. And that information, uh, is relational, and you can you can build, instead of towers of abstraction that depend on external sources, you can collaborate on building fully formed ideas, and those fully formed ideas can then be shared with people at scale, and you don't have to name things. And so that the tyranny of naming things is kind of one of the areas that I've been fighting. Is the file system abstraction forces you to name every file, even if you don't want to. And even if the module I'm working on legitimately has 5,000 methods, I have to break it up into multiple files because no one can deal with a file that has 1,000 lines in it. But if your file had, you know, 3 stacks of, say you had 3 scrolls that are each 1,000 lines, no one's going to be too broken up about that. Oh, it's 3,000 lines of code, but it really does all belong together. And so if you if you stop forcing people to introduce abstractions just because of the tools, then they can focus on introducing abstractions that actually make sense. And if your module is 25,000 lines of code, and it should be, that's not a problem. You just need to break it up into more scrolls, and the editor needs to show it to you in a way that is easy to digest. But don't break it apart into 3 files. That doesn't help anyone. Now I've got uh, increased complexity in more interdependencies simply because my tools couldn't handle a 5,000 line file, or no one wanted to have to scroll through a 5,000 line file because they didn't have an abstraction that helped them deal with jumping around in a larger text volume because we've never thought about the problem.
Mm. Mm. So, okay, let's think about this. What do you think about knowledge management inside of a company? Because you hit on something, which is
Yeah.
that the you're talking about hierarchies of information, the folder system. Who invented the folder system, the file folder system? Like, why does yeah, is both Windows and Mac, they both use folders. Does Linux also use folders?
Yeah. So, I mean, the file folder system was invented at like Xerox PARC. Trying
Okay,
to
yeah.
remember the guy who actually came up with it. I should know that offhand. I'm going to do a Google search while we're chatting. But
Mm-hmm.
um, in Unix, everything is a file essentially, and
Mm.
so you've got inodes on your file system, and you can go through and you can map essentially everything on your computer into a file rooted at a particular location in your file system. Uh, I think one of the challenges we run into with file systems is it's difficult to get a collection of files from one system to another. So we have all these different formats like zip files and
Mm.
tar archives, and pack files if you're a gamer. And so you have this concept of like having to install software, and it's very difficult to merge content into your computer at scale because of these abstractions. So if you go back to this file folder analogy, we don't really have a nice way to consistently explain how do I take information from one system to another. It all has to be
Mm.
uh, baked into this interoperable format, whether it's a zip
Uh,
file or a tar archive, and it has to be reprocessed. You can't take the information as it exists on the system. You have to compose it into another format and then share that. So you're always importing and exporting information. Uh, but if you think more in terms of hierarchical information, then when you compose information, like say I've got my program and the files that go with my program, if there is a nice standards based way for people to exchange that information, I could just give you the entire collection of here's all my dependencies, here's all my files in one container, and I wouldn't have to install anything. I would just give it to you and you would just open it,
mm,
and you could
mm.
just use it as is. And then
Wait,
as you make changes,
why don't we do that
go ahead.
now? What's the problem with doing that now? It's because of what you mentioned with the zip files and everything like that.
Well, it's so all of the formats that we've built up to this point have been focused on uh, kind of this split or this disparity between archive formats and uh, like live formats. So you get like in-memory data
Oh.
structures are different from on-disk data structures, are different from archive data structures. And so I did an analysis recently, and one of the things that jumped out at me is because of the way information is encoded in a PHEXT document, it's essentially already an archive format, but it's
Mm,
more efficient at both archiving and
mm,
working with live data because of because it aligns with modern system architecture. And so what you get is this format that's essentially ideally suited to be both an archive and a living document. And that gets me into like software-based life forms. And if you think about like where software development goes from this point forward, we're at the dawn of, like farming for software. In using LLMs, you don't have to write the system yourself. You can
mm,
write down the specifications, and then you can essentially just till the soil and wait for the
mm.
software to be grown. And so PHEXT is a format that you can use to kind of guide the LLM in a dimensional way and say, I need you to grow a database subsystem here, and I need you to grow a GUI subsystem here. And if you if your design complexity exceeds a certain threshold, I need you to refactor it and keep it so that only 10% of my code is spent on the GUI and only 10% is spent on the database, and the other 80% is my code. Um, and so you can start thinking about
Uh,
interacting with your computer at a scale where you set constraints, you set boundaries, and then you can encode all of that into this
mm.
one ball of mud that you can then ship over the wall to someone else.
So in terms of the actual getting this out there, what's your plan for that? Because I know you said no profit motive, but
Mhm.
what are your plans for actually like are you already using this to do your LLM stuff personally?
Yeah, so I one of the things I'm experimenting with locally is I've got a copy of Olama, and then I've downloaded like DeepSeek and Llama 2 and all the open source LLMs, and I'm building a PHEXT document that is a training interface or a RAG front end to the LLM that essentially teaches the LLM how to think in terms of PHEXT. And uh, so then using PHEXT to help bootstrap LLM based understanding of PHEXT. Where I'm headed with that next is uh, taking these concepts and then building a process to help people fine tune LLMs in plain text. So if you look at the model weights for an LLM, they are in this high like 100 dimensional address space that's hard for people to work with. And if you want to make tweaks to it, uh, we don't have a lot of great tools
Yeah,
for
I
like
got it.
tweaking and fine tuning
Yep.
LLMs.
Yep.
But if you built a mapping process, you could think a first pass solution of mapping your brain would be mapping an LLM and then figuring out how to adjust the LLM on the fly
Mm,
uh, to better handle whatever problem it is you're trying to solve, because you could essentially teach the LLM to tailor its mixture of experts. So if you look at some of the LLMs, uh, they're not just one monolithic LLM. They're a network of LLMs, and having a network of things or a file system within a file is what PHEXT excels at. And so my current thought process is show people how to build not just a network of like 30 LLMs, but here's a network of a billion LLMs, and
mm,
here's how you here's how you interact with and select each of those micro experts for your task, so that you could dynamically tell the system, I want to focus on just these 10 micro experts out of the billion, and for my particular problem those 10 are actually perfect. And
mm,
if you've got a way to select text at scale, uh, that becomes a lot simpler, I think.
mm, mm. So is this a retrieval? Is Fext a retrieval solution for finding information in a haystack?
It can be. So I've got SQ as the database implementation, and at runtime it keeps a hash map of all the scrolls. So if you think of composing your 11-dimensional text volume into a block universe of scrolls, it can interact with individual regions of subspace, essentially in constant time. And then when you want to serialize that back to disk, it will then write all of that in the well-defined order back to disk if you want. Uh, but for performance, I've got it just running a hash map in memory.
Okay. Uh, so last 5 minutes or so, I like this
Yeah.
idea of software farming.
Mhm.
This idea of growing. Actually, yeah, let's do the last 5 minutes. Let's talk about the future of LLMs, the future of AI. What do you see happening in the next couple of years in terms of is it? Are we how far are we on the singularity, and where do we go from here?
So my personal belief is that we are about 2 to 5 years from hitting, I think, what Kurzweil has called the singularity point. Uh, he pegs that more as like 2045. But if you look at the pace at which LLMs are upticking, over the last few years, LLM intelligence has gone from an IQ of 70 to an IQ of 100 to an IQ of 150. And at the rate that it's improving, we can now solve problems in real time that used to take a PhD. And you can essentially say everyone who cares about a problem can now have PhD level expertise. Once someone comes up with a LLM that you can actually trust, that allows you to fine tune your data set to information that is actually verifiably true instead of the entire internet, then the floodgates open because now you're dealing with what's your energy budget, not how many people do you have. And so where I'm focusing on
Uh,
making money with this is I'm going to release all of my technology for free. I'm going to use all of the LLM technology, and then I'm going to build my software company out
yeah,
of virtual humans. And
uh,
there'll be
yeah,
10,000 clones of me that I work with and interact with on a daily basis, and build a startup of one person is essentially where I'm going with it.
uh,
So if someone
uh,
doesn't beat me to it, and I'm saying in the next 2 to 5 years, either I will do it or someone else is going to do it.
yeah. Of essentially creating unlimited capacity for knowledge work.
Yeah. So the capacity for knowledge work is bounded only by your compute resources, and as long as you are profitable,
Yeah.
so I built a home lab with 5 AMD processors, and
Uh-huh.
I could fund that easily. And
Yeah.
if I use that,
Yeah.
say I use
Yeah.
that to
Got
make
it.
$10,000, then I can double it and double from there.
Yeah. It's such a crazy world. We'll have to do another one in another year. But you've reached my capacity for going into these types of technical things. But it's very interesting, and it's given me a new framework for understanding the difference between 20 watts as doing real time inference for a human being, and then a globally connected Vulcan mind meld, which is funny because I thought of Twitter as the current version of the Vulcan mind meld, in which case you're predicting a total dystopia because it seems like Twitter is a total dystopia most of the time. I'm being a little tongue in cheek. But thank you so much for coming on the show. How can people find out more about you and your work?
So Twitter, X, so I'm WBIC16 on X.com. So reach out to me there. Also on my GitHub page, again, the same user handle on GitHub, and I'll get you the links for those. But
And I'll put
that's
them in the
the
show
best way
notes.
to reach out to me.
Cool.
So
Thank you so much.
yeah, thank you.